5, they say that in the diagram below, we have triangle PMR is drawn with the vertex P, M, and R there. So this is the triangle. So you have the triangle there. They say that line MR passes through the origin. So now you know, they say the origin is what is O. So meaning that here the origin is what is O. You know that at the origin the coordinates there is 0 and what, and 0 for both what, for both x and y. For both x and y is simply 0 and 0. So now they say that the angle between what PR, this is the angle. So this angle here is given by what? By theta. And PR, this is PR. So PR is parallel to what? To MS there. So now they say that the equation of MS is given by y minus 5x plus 14, which is equals to 0. But if you have to check here, MS is a straight line. So we know that the equation of a straight line is given by what? By the standard form y is equals to mx plus c, where c, it is the y-intercept, and m being what? The gradient. So if you have to check the one that you're given here, it is not in the standard form. So what we're just going to do there, it is we're just going to arrange it first. So we're just going to make y the subject of the formula. So we're just going to say the equation of ms there is just going to be what? You take negative 5 to the right, it is going to be positive 5x. You take 14 to the right, it is going to be negative 14 there. So now you have the equation of ms in the standard form. So now they say that in 5.1, so this is 5.1, they say that we have to determine the equation of MR. So this is MR there. But if you have to check you don't have the coordinates of what? Of R. But you know something about this line MR, that this line MR passes through the origin at what? At O. So just going to say, okay, since O is in line MR, we are just going to use what? That point O there. Yeah? You know about collinear points, that whenever you have collinear points, guys, let's say that you have a point A, you have a point B, you have a point C falling on the same straight line like that. The gradient of what? Of AP, it is the same as the gradient of what? Of BC there. Why? Because these lines, and again you can say same as the gradient of what? Of AC, because these points what? Fall on the same what? On the same line. So those are called what? Collinear points. So if you have to check, MOR are what? Are collinear points because they fall on the same straight line. So just going to say, okay, this is not going to stop us from finding the equation of MR. We know that we need the gradient. Yeah? So to find that gradient, we're just going to say, okay, this is 5.1. Yeah? I'm just going to use points M and what? And O there, which is what? 0 and 0 there. So I'm just going to name this my x1, my y1, my x2, my y2. So now, to find the gradient first, we need to find the gradient first. So to find the gradient, or to find the gradient, the formula is given by what? By m, which is equals to what? Change in y all over change in x. So this is the same as y2 minus y1 all over x2 minus x1. So now we are finding the gradient between what? Between m and o there. So just going to say, okay, what is your y2? Your y2 is 0. What is your y1? Your y1 is 6. What is your x2? X2, that's 0. What is your x1? That's 4. So now you can see that 0 minus 6, that's negative 6. 0 minus 4, that's negative 4. Negative divided by negative, that will give you a positive 6 over 4. But now we can use 2. 2 goes into 6 how many times? It goes 3 times to 4. It goes 2 times. So now this is the gradient, what? MO there. So you're just going to say, okay, therefore now the equation of this line MR is just going to be what? So the equation MR is just going to be what? It's just going to be 3 all over 2x. You just replace the value of M there. So this is 3 over 2x. You don't have to worry going around and looking for the value of c, guys. Why? Because we know that this line passes through the origin. No? It passes through the origin. It means now the y-intercept is 0 there. So you don't have to worry about the coordinate of c. So this is what the equation of what of MR. So now let's take a look at the next question. So we have to determine what the equation of PR. So this is PR, and again, guys, if you have to check you don't have the coordinate of what of R, but you don't have to worry about that. Why? Because we know that this PR here, we have this angle. No? We have what? This angle here. And they didn't tell us anything about this angle. Yeah? They didn't say anything about this angle. So now this is the angle of inclination. Why am I saying it is the angle of inclination? The angle of inclination, remember, this is the angle measured from the positive x-axis to what? To the straight line there. Yeah? So now the angle of inclination, to find the angle of inclination, this is the formula. You see not theta, you see m is equals to what? Is equals to tan of what? Of theta. So this is the formula you can use to find the gradient of what? What is this? That line, the angle between what? The angle of inclination, or the agree you have the angle of inclination and this line there. So this is the angle formed between what? Between these two lines and what? And the horizontal line, which is what? The x-axis. So now we need to find the PR there. So but remember, guys, that we also know something about what? About the PR and MS. We know something about PR and MS, that the PR is parallel to MS. Whenever you have two lines that are parallel to each other, you use what? You use the gradient formula. Why are we using the gradient formula? We know that when two lines are parallel to each other, when you have line PR which is parallel to what? To MS, they have what? They share the same gradients. So they have what? They have the same gradient. They share the same gradient. No? So now you know the gradient of what? You know the gradient of what? Of MS, which is equals to what? Which is equals to 5. So it means also the gradient of what? Of PR is just going to be what? It's just going to be 5, because these two lines are what? Are parallel to each other. So now we're just going to start there and say, okay, already now we have gotten the value of M. So that's going to be what? PR is equals to what? Is equals to 5x plus c. To find c, you just use any points between, or you just use points P or R. But in this case, you have P, so you're just going to use P there. So now this becomes your x, your y. So your y is 4, which is equals to 5 into what? Your x is -2 plus c then. So now this 5 times 2, that's like 10, and that's -10. So you take -10 to the right or to the left is going to be +10. So +10 plus 4, that's going to give you 14. So therefore c is simply what? Is simply 14 there. So now therefore y, the equation of PR is just going to be what? 5x plus 14. So this is what? The equation of this line. So that's the equation of line PR there. So now let's take a look at the next question. So just going to solve 5.3. So now 5.3, they say what? They say that we have to calculate the size of what? Of theta there. So where's theta? This is a theta there. The one in red, this one, theta, this angle. Yeah, you can see this angle, guys. this angle here. So they're talking about that angle there. So they say that we have to calculate the size of theta rounded to 2 decimal places. So now this is when you're going to use what? We are going to use the angle of inclination. We're just going to start there. That's why it is 5 marks. So you're just going to say, all right, okay, let me remove this so that you see the flow. So this is 5.3. So now you're just going to start there. That m is equals to what? Tan of what? Of alpha. So tan of alpha. So this is the formula for angle of inclination, guys. Whenever you have the angle of inclination, this is the angle measured from the right toward to the straight line PR there. So now we know the gradient of PR, which is what? 5. So you put 5 is equals to tan of what? Of alpha. And then now to find the alpha, you say that alpha is simply what? The arctan of what? Of 5. So now let's see what value do we have there. So where's my calculator? So arctan 5, this is 78.69 degree. Yeah? So this is the angle there. So now you're not done. After finding this angle, now we have what? We have this angle. So to get to this angle, we can do what? Remember now we have 78.69 degree. So we can find this angle here by using what? The sum of angles in a straight line. Yeah? So just going to say, all right, I don't know what we are going to call this angle there. So let's what am I gonna call it? Let's see. We have alpha. Let's call it T, guys. I don't know if that's gonna make sense. Or alpha. Yeah, let's say this is alpha 1, this is alpha 2. Ne? Alpha 2. Whatever, guys, we wanna call it. But I hope you will understand. So I'm just going to say alpha 2. Ne? It's not the angle of inclination. I'm just going to call it alpha 2. Ne? It's just the naming. Or I should just give it another name, another variable. So let's say I don't know. Let me see. I'm just going to call theta 1. Yeah, let me say theta 1. Yeah. So theta 1, guys, this is the one here. So let me remove this. So theta 1. Yeah. So just going to say, all right, the sum of angle in a straight line add up to what? 180 degrees. Subtract 78.69 degree. The reason is because of what? Of sum of angles in a straight line. So now let me see what I have there. 180 subtract that one. So it means now theta. See theta 2, of course, theta 2. So this can be theta 1, theta 2. So theta 2 is just gonna be what? 101. Yo, look what's happening there. So this is 101.3. Let me round it to there. So this is 31 degree. So that's theta 2. So now you're not done. Now you know this angle here. You have this angle now to be 101.31. So now we have this angle here. We need this one here. To find this one, we need this one there. Understand? We need that beta there. So we need that beta. So just going to say, okay, let me move this aside. So I'm just going to say, okay, use this again, guys, this is the angle of inclination. This is the angle of inclination. The angle measured from the right to the straight line. That's the angle of inclination. So now just going to say, okay, it's m, which is equals to what? Which is equals to tan of what? Of beta. So now, what is the gradient of what? Of this line there that this angle of inclination is measuring? This line MR. We know that MR is the gradient of MR is what? Is 3/2. So you're just going to say, okay, this is going to be what? This is going to be 3/2, which is equals to tan of what? Of beta. So therefore, to find the beta, simply the arctangent of what of 3 all over 2. So let me see what answer I have there. Arctangent of what of 3 all over 2. So this is 56.31 degree. So now look, we have this angle. Now we can go back there and place it there now. So we can go back there. So we have this angle to be, what is that, 56.31. So I'm just going to squeeze it there, guys. So to find theta, guys, we're just going to use the sum of angles in the triangle. And which triangle is that? This one here, sum of angles in the triangle. No? So just going to say, all right, let's go back there. So I'm just going to write it here. Where can I write it, guys? Okay, let me just divide it like that. So I'm just gonna write it here is that theta is just gonna be what, 180 subtract what, subtract this one here, which we call theta 1, which is 101. So subtract 101.31 degree, and again subtract what is that, subtract 56.31 degree. And the reason is because of what? The reason is because of sum of angles in a triangle. So now theta now therefore is just going to be what, 180 minus 101.31 subtract 56.31. So now this angle become 22.38 degree. So this is the answer. That's the answer there. So rounded off to 2 decimal places. So now 5.4 showed that the coordinate of r is what, is -4 and 6 and -6. The where's r? This is r there. So now to find the r, guys, this is simple. We're just going to use the midpoint formula, né? The midpoint formula. So now we're just going to say, all right, let's use the midpoint formula. So this is 5.4. Why am I using the midpoint formula? I'm using the midpoint formula because we know that this coordinate here, I'm sure it is what, the distance, or the distance OR is the same as the distance what O M there. So I think that O is what, is the midpoint of what, of these 2 points M and R there. Yeah. So we're just gonna say that. So we're just gonna say, all right, let's go about that. We're just gonna say, all right, we know the midpoint formula is simply what, x1 plus x2 all over 2 there. So let me make a space, and then y1 plus y2 all over 2 there. So now what is our x1? Our x1 is just gonna be what, our it's just gonna be our x r plus what, our x m all over what, all over 2, and then what, our yr plus what, our ym all over 2 there. It's like we're trying to find the midpoint there, but we already know the midpoints there. We already have what, the midpoint, which is what, the origin there. Yeah, we already have that thing there. So just going to say, okay, what is xr? Xr will be xr there, so that's xr. But what is xm? Xm, if you had to go back there, is 4 all over 2. And then what is your x, your yr? Your yr will be yr, and then plus your ym. What is ym? Ym will be 6, and then all over 2 there. But we know that the midpoint here is supposed to be 0 and 0. You know that, guys. We have the midpoint O there, which is the origin. It's supposed to be 0 and 0 there. So what we're just going to do is to say, okay, This thing here, the xr plus 4 all over 2, this is to equals to what? To 0 then. Yeah? And the yr plus 6 all over 2, this is equals to 0. So I'm taking the coordinates of what? Of the midpoint, which is what? The origin there. So now we're just going to say, okay, to do the cross multiplication there, 0 times 2, that's going to be 0. It means you have xr plus 4, which is equals to 0. So now, therefore, xr is simply negative 4. And then now, when you do the cross multiplication, you'll have 2 times 0, that's 0. So now, your yr plus 6 is simply 0. So therefore, your yr is equals to negative 6. So now, therefore, the coordinate of r would be negative 4 and what? And negative 6. So if you have to check there, this is exactly what we have. Yeah? So it's the same thing. So now, let's see, we have 5.5. They say that we have to calculate the length of what? Of mr. Where's mr? So this is mr. You have to find the length of mr. So now we know something here, the coordinate of what? Of r, which is negative 4 and what? And negative 6. So yes, that's what we have. So we have to calculate the length of mr in the simplified third form. So just going to use the distance formula. So that's 5.5 then. So I'm just going to write it here. So just going to divide like that. So 5.5. So using the distance formula, which is equals to the square root of what? Of x2 minus x1 squared plus y2 minus y1 and then squared. So now this is what the distance mr. So remember, r is simply negative 4 and the negative 6. And then m, let me see, what's m there? M is 4 and 6. So this is 4 and 6. So now just going to say, okay, this is what the square root of what? You can name this your x1, your y1, your x2, your y2. So your x2 is going to be 4 minus your x1, that's negative 4. And then squared plus your y2, that's 6, minus your y1, that's negative 6. And then you square it like that. So now let me take out the calculator. So that's 4 minus 4 squared plus 6 minus 6, and then squared like that. So this is 4 square root of what? Of 13. So you can see units, since it is the distance, so units. So that would be your answer there. So now let's take a look at 5.6. So 5.6, they say we have to calculate the area of what? Of triangle PMR. So now let me clean this a bit, guys. Let me clean this, no? So now let me just clean this. So let me clean this. Just gonna remove this. So now this is 5.6. They say we have to calculate what? The area of triangle PMR. This area of the triangle PMR. So I'm just going to use this formula, guys. Remember, to calculate the area, you have, I think, two formulas, if I'm not mistaken. You have this one, half base times height. You have again half into what? Into a time AB multiplied by sine of what? Of angle C. So now this is the formulas that I know. So just going to use which one? We don't know the height of this triangle. So we're just going to use what? Number 2 there. So half into AB times the angle of what? of C. But what is this angle here? And what is A? What is B? What is C? A, this is what the side adjacent to what your angle. So in this case, our angle will be theta there. So you can call this our adjacent angle. This is gonna be our adjacent side is gonna be half of what of PR. So that's gonna be PR multiplied by what this side here, which is what MR. So MR multiplied by this sine of what of the angle of what of R. So but check, for us to use PR, we need what? The length of PR. And for us to use MR, we need the length of MR. So let's go there and calculate the length of PR, the length of MR. So first, I need the coordinates. I'll start with P. The coordinate of P is what is -2 and 4. So -2 and 4. And then R, I know this is -4. And the -6, and the M is simply 4 and the 6. Yeah, 4 and the 6. So yeah, let's do that. So just gonna say, okay, let's find the distance of PR. So remember, we have something like this, where this is P, where this is R, where this is M, and we have this angle to be theta. So we need this side, there. So the distance PR there, we can simply say PR is equals to the square root of what? I'm just going to say this is my x1, y1, x2, y2. So using that formula there, your x2 will be -4 minus your x1 is -2, and then squared plus your y2 is -6, your y1 is 4. So let's see what we have there. So the square root of what? Of -4 minus 2 squared plus -6 minus 4. Let me include that plus -6 minus 4 squared. So let me see why I didn't square here. That's why I'm getting errors. So I have 10. So that's 10. So it's 10 units. And then let's find, we also need MR. So let's find MR. So I'm just going to name this our X1, our Y1 there. So now, this is the square root of what? Of your X2. So your X2 is -4 minus your X1 is 4, and then squared plus your Y2. Your Y2 is -6 minus your Y1 is 6, and then squared. So the square root of what? Of -4 minus 4 squared plus -6 minus 6, and then squared. I have 4, and we calculated this case. It's here. So we calculated this to be there, but it's fine. So now we know this angle, né? We know this angle. We calculated that angle. Where's that angle? It's here. Yeah, it's 22.38. So that's 22. So we know this angle is 22.38, and that's in degree. So now the area of triangle PRM is just gonna be what? The half of what? Of we're not gonna say A times B. In this case, we're just gonna say PR multiplied by what? By RM, and then sine of what? Of the angle. So it's the included angle. So these are the sides that are adjacent to your angle, the side adjacent to the angle, and then the included angle. Remember, the formula is what? Is area is equals to half AB sine angle C. So I'm using that formula there. So just gonna say, all right, this is half. Your PR is 10. Your RM is 4 square root of what? Of 13 sine of what? Of the angle, which is what? Let me remove that thing there. So sine of what? Of 22.38 degree. So therefore, the area of triangle PRM will be half into 10 and then 4 square root of what? Of 13 multiplied by the sine of what? Of 22.38. So now this is giving me 27.45, but I round it to two decimal places, so that's 46 degree. Not degree, this is area, so 27.46, and then this will be units squared. So units squared. So that's the answer there. So now they say that this one, I'm just going to write it here. So they say that we have to write down the coordinate of S. If it is further given that PM is parallelogram, so if PS, if what? If PM is, and then R is a parallelogram. So if this is a parallelogram, so guys, you have to know the properties of a parallelogram. So the property the properties of a parallelogram, guys, this is that the opposite what? The opposite sides are what? Are parallel and also what? Equal. So this one here is parallel and equal to what? And also equal to what? To the longest one there. And then the diagonals bisect each other. So the diagonals bisect each other. So you can see the bisect here at the origin, which is simply 0 and 0 there. So we have to find the what? We have to find the coordinate of S there. So they say write down the coordinate of S. Remember, this is what? This is -4 and then -6. -4 and -6. So now they say write down as if something is given. Seems like it is given, guys. Remember, the length of PM is equals to the length of what? Of RS there. So if you have to check, you have -4 from -4 to 4. You added what there? It's like you added 6. Yeah, you added 6. So plus 6 for X. You added 6. It will give you 4. For Y, let's see, for Y from 4 to 6 is like 4 plus 2, and then you'll get what? You'll get 6 there for Y. So it seems like here we'll say -4, and then you add what? You add 6. So -4 plus 6, this will give you 2. And then for -6, you say -6 plus 2, this will give you -4. So this is giving me -4 there. So this is -4. So yeah, that's what I have there. So -4. Let me double check. -6 and then a plus, what is that? Plus 2. So I have -4. Yeah, that's what I have there. So those are the coordinates of what? Of S there. So I can simply conclude and say, therefore, S is simply 2 and -4. So that's what I would have. Or you can use the midpoint formula. So the midpoint formula, just going to say, okay, this is going to be the x plus the xp all over 2, and then what? The ys plus what? The yp all over 2 there. So the xx, the x answer there, you don't have it, but the xp, that's -2 there. So just gonna say, okay, this is -2 divided by what? By 2 there. And then you have to equate this to what? To the origin there, which is 0. And then the other part is gonna be ys plus what? the yp, which is 4, and then all over what? All over 2. This is equals to what? This is 2 equals to 0. So now, let's see, we're just gonna say, okay, this is going to be x. You see, when you multiply this, it'll give you 0. So you have x is equals to, it'll give you 2, guys. You can see, well, let me just make it easy for you. You have x minus 2 is equals to 0. You take this to the right, it is going to be what? X is equals to 2. Same thing here, it will be ys is equals to what? Negative 4, same as what we got. So it's up to you guys, which one you understand, né? So yeah, make it easy for yourself. So now let's take a look at the next question. This is question 10. So now they say in the diagram below, we have M, which is unknown M and 3 there. So it's the center of the cycle. Doesn't look like the center there, but it's fine. So since it's the center of the cycle there, it means now the radius is gonna be from the center to the circumference. So like that, guys, you can see how weird it is. So yeah, that's what you have there. And then you have Q, which is the midpoint of the chord AB. So okay, they told you that that's the midpoint. You have A is given, you have B with a known x value. The length of the radius of the cycle is 10. The length of the radius, so the radius is simply what? 10. So let's remember that for advanced name. So let's put that for in advanced case. So now they say that we have to calculate the value of A and the Q. So calculate the value of A and the Q then. So let me first remove this. Remember, don't forget about this one. So that's the radius there. Let's put that for advanced name. So we're just gonna use this in advance. So now calculate the value of A and Q. A and Q. So now we're just going to use the midpoint formula again. Yeah? So now remember the midpoint formula says, so I'm answering 10.1. It says the midpoint is equals to what? X1 plus X2 all over 2, which is what? The Y1 plus the Y2 all over what? The 2 there. So now, but we have the midpoint, guys. Yeah? Remember, this one has to give us the midpoint, which is what? The X value at the midpoint, the Y value of what? Of the midpoint. But since you have those, you're just gonna equate it with what? With this part of what? Of X. So you're just gonna say, okay, this is what? This is the X of what? Of A plus the X of what? Of B all over 2 into what? Let me just equate this to 0. So this is to not equals to 0, is equals to the X, the Y, so it's equals to negative 4. And then you also have what? You also have this part. So I'm just gonna say this is the Y of A plus the Y of B all over 2. This is equals to what? To the to Q there. So it's equals to Q. So what is XA? XA is negative 12. What is XB? XB is A all over 2 is equals to negative 4. So now when we solve this, let's see, do the cross multiplication. 2 times 4, that's negative 8 is equals to negative 12 plus Q. So therefore Q will be what? You take this to the left. So you have a negative 8 plus 12. So you have 4 as your value there for Q. And then for this part, the YA is gonna be negative. Okay, that's not negative. So YA is 2. So this is XY. So now that's 2 there. So 2 plus YB, that's 11 all over 2 is equals to what? Is equals to Q. So do the cross multiplication, we left 2Q is equals to 2 plus 11 divided by 2 divided by 2. So this rationalize, therefore Q is what? Is 2 plus 11 divided by 2. So I have 18 all over 2, which is approximately 6.5. So those are the values of Q and what? A and Q, guys. See what I've done there? This is A, guys. The way I write this is A, guys. Sorry. This is A. Remember, we took this A is the Y, is the X value there. So this is A, and then you left A, and then you left A. Yeah, that's it there. Sorry for that. So now calculate the value of M. So let me first erase this. Okay. So to calculate the value of M then, so to calculate the value of M, check. This is M here. M is the what? Is the center there. So you're just going to say, all right, to find the M, let's use the distance formula. We're just going to calculate the distance formula of what? Of these two, or use these ones. Yeah? It's up to you which one you want to use. So, but since you have the value of what? Excuse. Oh, let me just use this one. Let's use this one. Yeah? Let's pretend as if we didn't know the value of Q there. Yeah? So, like let's say you skipped 10.1, so now 10.2 is for you guys. So just gonna say, okay, let's use the distance formula. So the distance formula, just gonna calculate the distance formula of what? Of MA there. So remember the distance formula is D is equals to what? The square root of what? Of x2 minus x1 squared plus y2 minus y1, then squared. So now, so the distance AM is just gonna be what? It's just gonna be the square root of what? Okay, let me make sure that I write this nice. So AM is equals to the square root of what? Of our x2. So I'm just gonna say this is x1, y1, x2, y2. So your x2 is what? Is M minus your x1 is -12. So protect and then square it. Your y2 is what? Is 3. Your y1 is 2. And then square it like that. So now, just gonna say this is equals to, so let's see. You have what here? You have, okay, let me first deal with the inside. So I have something like this. So now, this is M minus 12. So see, the negative, multiply the negative inside there. You'll have what? You'll have a positive 12. So that's like M plus what? Plus 12. And then square it like that. And then 3 minus 2, that's 1. So you have 1 squared. But see guys, this thing here is equals to what? AM. But what is AM? AM, this is the radius from M to A. That's the radius from the center to what? To the circumference of what? Of the cycle. So that's what? The radius. So I'm just gonna write it here. So from that thing to that part there, that's what? The radius. Yeah, that's R. So but we are given the value there. That R is 10. So you simply just gonna equate this to what? 10. So simply say this is equals to 10 like that. So now to find what? To find the value of M, you simply square both sides. So you square both sides like that. When you square the 2 and the square root rationalize, so you have what? You have M plus 12 squared plus what? Plus 1, which is equals to what? 100. Yeah? 10 squared, that's 100, guys. So that's 100 million, that's 100. So now, you say this is what? This is M plus 12, and then what? And squared like that. Take this to the right, you'll have 99. So 100 minus 1, that's 99. So take the square root, take the square root. But remember, when you take the square root, you have plus and minus. So you'll have plus minus the square root of what? Of 99. So the 2 and the square root rationalize. You have M plus 12, which is equals to plus minus the square root of what? Of 99. So therefore, the M has to be what? So m has to be, remember this is a small m, guys. Now don't be confused that this is the code, this is this is the small m there. So that's the small m. So this is equals to what? This is to equals to -12 plus minus what? The square root of what? Of 99. So if you have to check there, guys, we have two choices for this value of m, guys. It's either we have a -12 plus the square root of 99 or -12 minus that. But if you have to check the m is what is between -12 and what, and this value here, this value of a, remember, is 4. So it's between negative what, 12 and what, and 4 then. So it has to be greater than -12 for us to have a value that is greater than -12. Since you can see that m has to be greater than -12 there. Now, the value of m there has to be what, greater than -12. So it means we need what, a positive value there. So it means we're just gonna say m is equals to -12 plus the square root of what, of 99. So let me see what's that. -12 plus the square root of 99. So the answer that I have is what? Is -12 plus 3 into the square root of 11, which is approximately what? -2.05. So this is our answer then. You can leave it here or leave it there. No? So that's the answer. So now I can come back and fill it. So m is simply, what is this? So I have a -12 plus 3 into square root of 11, which is approximately -2.05. So now they say if the coordinate of m is -2 and 3, you see, it is -2. Say it means they rounded it to what? To 1 decimal then. No? They rounded it to 1 decimal. Or did they just took this as what is this? Rounded it to what is this? The 0 decimal, guys. Understand? 0 decimal. So they have like 2.000 there. So they rounded it to 0 decimal there. So you can still the this value is still correct, guys. Ne? You can see it is close to -2. Ne? It's the same thing. So now they say if m is this, determine the equation of what? Of the cycle in the form of. So guys, we're not gonna waste time there. If m is the, we know that m is what? Is the center. No? Is the center of the cycle. So it means now for us to write this equation of a cycle, we just need the value of what? Of a, the value of what? Of b, and we are going to find that by using what? The coordinates of what? Of the center. So just gonna say, okay, that's gonna be x minus what? Your a is what? Is 2 there. So that's -2, protect like that, then square it, plus your y minus b, which is 3, and then square it. But what is r? R, we know it is what is that? It is 10 there, no? It is 10. So you simply say 10 and then squared. So now this is going to give you what? So therefore this is going to be x plus 2 squared plus y minus 3, and then what? Squared, and then it's equals to 10 squared, that's like 100. Yeah, so that's the equation of what? Of the cycle. So now determine the equation of a tangent to a cycle at point A. Determine the equation of a tangent to cycle at point A. So it's like you have a tangent now at point A. So let me picture this for you. Hey, that's not a tangent. Look, okay, let me just erase this. So the equation of the tangent, guys, I'm just gonna picture it for you. So it's just this, so it has to be more like that. You see, that's a tangent. So to find the equation of a tangent, remember, we know that this is the radius, this is r there. So now we're just going to say, okay, To find the equation of this line that cuts at A, or that is a tangent at A there, we're just going to use this formula. The product of two gradients, this has to give us what? -1. So we can call this our M2. We need the M1. So let's go and find out. Let's go and find out and calculate the what? The gradient of what? Of AM then. Yeah. Remember the value of M is -2. So let's go and find the gradient of what? Of AM then. So just gonna say, all right. So this is supposed to be okay. Let me just write it here. So let's find the gradient of what? Of A. Is that A? Yeah, AM. So the gradient of AM is changing Y all over changing X. So changing Y over changing X, you can call this what? Your X, your Y, Y1, Y1, X2, X1, Y1, X2, Y2. So now our Y2 is 3. So that's gonna be 3 minus our Y1, which is 2, all over our X2, which is M, in this case is -2, minus our X1, which is -12, so -12. Then let's see what we have there. So this is 3 minus 2, all over -2 minus into -12. So I have 1 all over 10 there. So I have 1 over 10. So let me just write it nice. 1 all over 10. But let's check something, guys. This is determine the equation of a tangent to the circle at point A. At point A. We don't know, guys. But yeah, M has to be what? This radius here has to form a 90-degree between what? Between the line, which is the tangent, and what? And the radius then. So it has to form a 90-degree. So we can use that. Well, let me say something. If I say 3 minus 2 minus, then I stick to that one that I was given, which is -12. What was that? 3 minus, let me go back there. This is y2 minus y1 x2, okay? And then over 2 into minus 2, let me see, 2.05 minus 12. Just want to check something. Okay, still the same thing. So now this is the gradient of what? Of AM. So just gonna say, okay, we have this formula that says that the M1 multiplied by M2 is equals to -1. So your M1 is that, so 1 all over 10 times M2, this is equals to -1. So therefore, your M2 has to be what? Has to be -1 divided by that. So -1 divided by 1 all over 10. This will give you -10. So your answer is -10 then. Yeah, and it makes sense because you can see that the slope of this tangent is what? Is decreasing like that. No? So it is decreasing. So now to find the equation, you're just gonna say therefore. So I'm just gonna use black. So therefore, y is simply what? Is simply -10x plus c. To find the c, just going to use point A there, since the tangent cut at what? At point A, or the tangent is at point A there. I told you that the equation of a tangent to the circle at point A. So it is at point A, use that point there where the tangent is. So now point A is what is that? It's -12 and 2. So that's -12 and 2. So now I'm just gonna say this is my x, this is my y. So your y is 2, which is equals to -10. Your x is -12 and then plus c. So therefore your c It's just the summation of those. So negative 10 multiplied by negative 12, I have 120. So now I will say 120. Yeah, let me see, what was the answer? 120. So 120 into 2 minus 120, then 1118. Wow, negative 118. Determine the equation of a tangent. Wow. So that's y is equals to, what is this? Is equals to negative 10x into, what is that? Negative 18. 1118 then. So this is your answer like that. Yeah, that's it. So let's see, negative 12 and then 2, and then you plug it there, you have negative 12, and then times that give you 120, and then yeah, that would be it. So I think it makes sense, guys. Yeah, makes sense. Makes sense to me. So now let's take a look at this one. So we have question 13. So they say that in the diagram below, center W on the circle lies on a straight line 3x plus 4y plus 7, which is equals to 0. The straight line cuts the cycle at V and Z is that. So now, so here, guys, you're just gonna learn more about the intersection of cycles. So I think I have to first teach you that. So now let's first learn about that, the intersection of cycles. So where can I, okay, let me just write it here. So the intersection of cycles. So now, let's say you have a cycle like this, and then another small cycle like that. Yep. And then you have a radius. Or let me just, let me try again. So you have something like this. So let's say this is your radius, and you can call this center A. Then this will be B, and then this should be your radius A. This will be your radius B. Then, so now, if you have to check, this will be the distance between between the two, the distance between their centers. Then, so now, whenever you have this case here, you can see there's no intersection. So here is when you have what? No intersection. So I'm just gonna write it here that this one, no intersection. So whenever you have no intersection of the cycle, this is when what the distance between what their centers, which is A and B, is equals to what? Is equals to what is this? Is equals to the sum of what? Of their radius. So A and B. So let me write that down. Nice. So let me say RB RA so that it makes sense. So RB plus RA. Since RB, you can see that this is the bigger cycle, and RA, this is the small cycle. So now that's number one there. Number two is when you have this condition. Let's say you have a cycle like this, and then you have what? Let me do it nice. You have a cycle like that, and then you have that small cycle like that. Then this will be the radius. So in this case, guys, I should have like say this is your RA and then B-ish. Look what's happening there. So this is A, and then this should be our B, and then now it should make sense. Say A plus RB. So this is A, radius A, and then radius B. This is center A and center what? B. So now the distance is this one here, the distance D, the distance D. So now you can see here you have what? You have intersection. So this is 1 point. So you have 1 point where the intersection happens. So it happens only 1 point. So wherever you have this case, the distance between A and B is what is less than. Now this one is 2B equals to, no, we have equals to already. So this has to be, let me see, this is equals to, and this has to be, yeah, this has to be equals to, guys, sorry for that. This is when you have the distance to be greater than the sum of their radius, and then this is when you have what? Equal sign. So now whenever you have this, it's just going to be what? The radius of A plus the radius of what? Of B. So the sum of their radius is that. So these are the formulas, guys, that you're going to use whenever you see that they're talking about the no intersection only at 1 point. You calculate what? The distance between their centers, and if it is equals to the sum of their radius, it means you only have one, or there's only one intersection, or the intersection only happens at what? At 1 point. Understand? And then here you calculate the what? The distance of what? Between their centers. And then if you find that it is greater than the sum of what? Of their radius, it means now there is no intersection there. So now number three. So number three, let me just. So number three, you'll have this, and then let me write that nice again. So you have this big cycle like that, and then like that. So now this is when you have what? You have, this is 2 point. So now you can see the intersection happens what? At 2 point. So here at here. So they intersect at two distinct point there. So it means now the distance. Okay, let me first use we have to call this the radius R A, and this is A, and this the radius RB, and this is B, and this is the distance. So now this is the formula that we'll use when they're talking about 2 point intersections. So the distance between their centers is less than what? The sum of what? Their radius, where RA is the bigger cycle and RB is what? The smaller cycle. So yeah, this is a small scope that you should have, guys. Now, so use this, it will help you. So now I think we should like go through the questions together. So now let's see. We have the first question there. Let's see for coding. Okay. So we have the first question. They say that we have to determine the equation of what? Of the cycle in the form x minus xa plus y minus b, which is equals to r squared then. So now, to find the equation of this cycle, guys, remember this will be your radii. So from W to G, that's the radius there. So you're just gonna say, okay. So I hope you already have this, guys. I can erase it now, or I should. Where can I write this? Because I need this space here, guys. I hope you copy this ready. So now let me erase this. So this is 13. What's that? 13.11. So they say that we have to determine the equation of a cycle in the form x minus a y minus a b there and r squared. So we need to find what is a, what is b, and what is r for 5 marks. So just going to say, okay, we know the coordinate at w has to be what? Has to be x and what? And 2 there. Why 2? You can see that whenever you draw a straight line like that, or a horizontal line like that, the y coordinate there, or the y intercept, or your horizontal line that you have drawn there will be what will give you the y coordinated what at w there, because it's just the straight, it's just the horizontal line like that. Yeah, it matches with g there, so it means the y coordinate of w will be 2. So already you have your b there. So now to find the x value there, remember we are told something that we have this straight line. Now the center w of the cycle lies on a straight line. 3x is equals to that. So now, since they're talking about the straight line, we know a straight line has a standard form of what? Of y is equals to mx plus c. So we can write this in the standard form. So you have what? Let me first write that nice, or as it is there. So we have 3x plus 4y, which is plus 7, which is equals to 0. So now to make y the subject of the formula, we'll have 4y is equals to negative 3x minus 7 divided by 4 divided by 4 divided by 4 there. So therefore now your y is simply negative 3 all over 4x minus 7 all over 4 like that. So now this is the equation of what? Of this straight line. So it's gonna be vz there. So this is your vz. So vz is given in that format. So now we know the value of what? Of y there. But remember that w lies in line what? In line vz, this straight line there. So we're just going to use this straight line to find the what? The x value there at what? At w. So just gonna say, okay, this is y is equals to negative 3 all over 4x minus 7 all over 4 there. You know the value of y. The value of y is what? Is 2, which is equals to negative 3 all over 4, and then x minus 7 all over 3. Why am I using this equation? Because w lies in line what? Vz there. So we can use this equation of a straight line to say, okay, if y is 2, what is x? Understand? So take this negative 7 over 4 to the left, it's going to be positive. So 2 plus 7 all over 4, this will give you 15 all over 4, which is equals to negative 3 all over 4x. So now you can simply divide by negative 3 all over 4 both sides, negative 3 all over 4. So this rationalize, so therefore your x will be what? 15 divided by negative 3 all over 4. So I have x to be negative 5. So it tells me that now my equation is simply x minus what? Remember, it's x minus b, then squared x minus a plus y minus b, and then squared is equals to what? R squared. So we have these values now. So we're just going to say x minus 5, and then squared like that, plus y minus what? The 2, and then squared is equals to what? R squared. To find the r, I'm just gonna use the distance formula. So you're just gonna use the distance formula. You can use WR there. Yeah, just gonna use WR. So now let me find the distance formula. So I'm just gonna say W, or the distance. Remember, the distance formula is just gonna give us the length of what? Of WG, which is what? The radius. So it's like we're finding the radius. So the radius just the square root of what? Of your x2. I'm just going to say this is our x1, y1, x2, y2. So your x2 is 0 minus your x1 is negative 5. Your y2 is 2, your y1 is 2. And then square root like that. So the square root of what? Of 0 minus 5, and then squared, plus, okay, plus 2 minus 2, and then squared. So r is simply 5. So now this tells you that the equation of the cycle with center w is simply what? Is simply x plus 5, and then squared, plus y minus what? Minus 2, and then squared, which is equals to what? 5 squared. So this 5 squared is going to give you 25. So 5 squared, that's 25. So now your answer is that. So now this is determine the length of what? Of VZ. So the length of VZ. Where's VZ? So VZ is simple, guys. Remember, from W, which is the center, to V, to the circumference. So V is at the circumference of the cycle. So that's like the radii. So now it's also the radius, this one. So remember, the radius will also be 5 there. But they need what? The length or the diameter VZ. The diameter VZ. So it means now that's the radius again plus the radius again. No? So it means that's what? That's gonna be, so VZ, that's gonna be the radii multiplied by 2. That will give you the diameter. So the radii is 5 multiplied by 2. This will give you what? This will give you 25. Oh, this will give you 10 or 25. It will give you 10. So you can say units. So 5 times 2, that's 10. So now calculate the gradient of G. There. The GZ, this is from this point to that point there. So you just need what? You just need to use the gradient formula. So that's gonna be mgz. So they're just looking forward for the gradient. So this will be your x1, your y1, your x2, your y2. So remember that to find the gradient, this is changing y all over changing x. So changing y, that's negative. That's negative 1, which is y2, minus y1, which is 2, all over x2, which is what? Negative 1, minus x1, which is 0. This will give you the gradient. So now let me see. Negative 1 minus 2, negative 1 minus 0. So the gradient is simply what? Read them. That will be it. So now let's take a look at next one. Write down the coordinate, the coordinate of the midpoint of GZ. Again, GZ. So now I'm just gonna write it here. This is 13.1.4. So 13.1.4, they're looking for the coordinate of the midpoint of GZ. So remember the midpoint formula. This is what? The x1 plus x2 all over 2, which is the y1 plus the y2 all over 2. So now your x1 is what? We're just gonna use GZ, the points G and Z there. So Z is what? Is negative 1, and the y value is what? Is negative 1 there. So now your x1 will be 0. So that's 0 plus, well, let me first show you how it works. So you're just gonna say this is the xz, yeah, or simply xz. So xz plus the x what? Xg. This is to be xg, guys. Why? Remember, I gave them the naming that this is should be the x1 plus this is the x1 x2. So it means that x1 is what? Is the g, x2 is what? Is the z there, and then all over 2. So this is the yg plus the yz all over 2. So now looking for the midpoint. So now the midpoint is just gonna be what? What is the xg? So that's 0 plus the z is negative 1. So let me see, plus negative 1 all over 2. Yg, that's 2, minus or plus the yz, which is negative 1, and then all over 2. So now let me see. So this is negative half. Okay, so negative half, 2 minus 1, that's 1. So this is half, like that. So it means now the midpoint what? GZ. So midpoint GZ It's simply that. So now let's see if I still have a space. So I'm just gonna divide it like this. So this is 13.1.4. I'm gonna name it as 13.1.5. So 13.1.5, we have to determine the equation of a line that is perpendicular bisector of what? Of GZ. Of GZ, perpendicular bisector of GZ. So perpendicular bisector, this is when you have something like this. So whenever you have, in that case, guys, whenever you have this situation here, you simply need the M1 and the M2 and then get their product, which is equal to -1. Now, just gonna use that formula whenever you have two lines that are perpendicular to each other. So first, we know the gradient of what? Of GZ then. So to find the gradient of what? Of the bisector there, that's very simple. But first, let me check something. Remember, this is y2. I said y2 minus y1, which is -2, and then x2 -1 minus, okay, makes sense. So now, where is that? So now you have m1 multiplied by m2 is equals to -1. Your m1 is 3, your m2, which is the perpendicular bisector, so divide by 3, divide by 3, this rationalize. So m2 is simply what? -1 all over 3. So it means now just have y is equals to -1 all over 3x. To find the c, just gonna use a point there. And which point? So just gonna use the midpoint. No, just gonna use the midpoint. It says determine the equation of a line that is perpendicular bisector of GZ. Perpendicular bisector, it means it's gonna cut this line in half. This one here, this from A to B, as to equals to what? From A to C there. That's perpendicular bisector 90, 90 there. So since this line is a perpendicular bisector to GZ, it has to be at the what? At the midpoint there. So just gonna use the point where the bisector is happening, where the bisection is happening there. So just gonna use the midpoint. So we have the midpoint coordinate, which is that. So it means this is your y there. So that's half is equals to -1 all over 3. Your x is negative half and then plus c. So let me check this up. So you have -1 all over 3. That will give us 1 over 6 multiplied by -1 all over 2. That's gonna give you 1 over 6. So now a half, subtract the 1 over 6. So c is simply what? Is simply 1 all over 3. So therefore, this perpendicular bisector equation is going to be y is equals to -1/3 plus 1 all over 3. And this will be it. Now, this will be it. So now, show that the line in what? The line in 4.1.5, okay, that talking about this one here, and the straight line VZ intersected W. We have to show that the line in this line here that we calculated to be, we determined to be this, and the straight line VZ, we are given the equation, they intersect. We have to show or prove that they intersect at W. Now, remember, when two lines intersect, they share the same what? Y coordinate there. Let's say that you have what is this? You have a parabola, and then you have a straight line like that. Let's say that the straight line is cut there, and that's, we call that W. To find the coordinate of W, you know that you're just gonna equate the two equations, the straight line and what? And the parabola. So you're just gonna equate them. Why are you equating them? This shows where the intersection happens. Now, when you equate the two functions, it shows you where the intersection happens because they share the same what? Y coordinate. So you're just gonna say, okay, what is the equation of VZ? And we have the equation of the bisector there, the perpendicular bisector. So VZ is this one. Yeah. So that's what. So let me write it here. That's is 13.1.6. Yeah, 13.1.6. So the equation of VZ, this is what this is negative 3 over 4 into that negative 3 all over 4x minus 7 all over 4. This one then. Let me go there so you can see this one. And then you have the perpendicular bisector, which is what y is equals to negative 1 all over 3x plus 1 all over 3. So we have to equate the two equations. You know? So let's equate the two equations. So all of them, you see, it's y, it's y. All of them there was to y. So you equate them to find the x value. So negative 3 all over 4x minus 7 all over 4. This is equals to what? Negative 1 all over 3x plus 1 all over 3 then. So now this is what you have. So you group the x to the x, constant to the constant. So now negative 3 all over 4 plus 1 all over 3. I'm taking this one to what? To the left there. Yeah, I'm taking that one to the left. So I'm taking that one to the left. So now I have what? I have a negative. Let me remove this. I have negative 5 all over 12x, which is equals to. So you take this one, negative 7 over 4 to the right. So you have 1 all over 3 plus 7 all over 4. And I have what? 25 all over 12. And then you can simply multiply by the reciprocal of this, which is going to be 12 all over negative 5. Multiply by 12 all over negative 5. The 12, the 12, the 5, the 5. So therefore, x is simply what? 25 all over 12 multiplied by 12 all over negative 5. So x is simply negative 5. You take this and substitute where you don't substitute it anywhere, guys. Be careful. This is a VZ. This is the bisect. You're not gonna substitute it to the bisect. Yeah? Oh, first, let me show you. Let's substitute this value to the bisect. You'll have negative 1 all over 3 into negative 5 plus a third. The answer is still 2. All right. Let's try again. 3 over 4 into negative 5 minus 7 all over 4. The answer is still 2, guys. It works, guys. Sorry for that little confusion there. No? Sorry for that little confusion there. So it works, guys. It has to work. Make sure that it works. Yeah? Because why it works? These two equations here, we equated them, yeah? Meaning whenever we equate them, the values that we are gonna get, they are the same for both what functions. And the x values, they are the same for what? For both functions. Only where the intersection happens. Understand? So after finding that value, let's say for y or x, take that value, substitute to any of those two equations. Everyone? So now I'm just gonna substitute here because this is the simple one. So that's y is gonna be what? Negative 1 all over 3. So this is negative 5 plus 1 all over 3, which is equals to. So I have negative 1 all over 3 minus 5 plus 1 all over 3. So the answer is 2. So you can see, guys, this way what the coordinate of W. You see, x is equals to negative 5 and y is equals to 2. So now the question was what? The question was show that the line in 13.1.5 and the straight line VZ intersected W. So if they intersected the W, they have to have the same coordinated as W. Ne? Remember W is what? Is negative 5. and what and 2. They have to have the same coordinate as W there. So therefore, those two lines intersect at what? At W. So I'm just gonna say therefore, uh, therefore, the two lines intersect at W, which is W, which is -5 and the 2. Or we can say, let's first deal with this, né? Let's make sure that they know what we are doing. So we're just gonna say, okay, since just gonna say since x is equals to -5 and y is equals to 2, né? Which is the same as the coordinates of W. Therefore, the two lines intersect at W. So which is -5 and what? And 2. And we are done like that. So now let's see. Next question. So yeah, I'm so tired. Let's see. Right. So we have this one. They say that the cycle defined by x plus 2 and plus y minus dot has a center M, and what? The cycle defined by x minus 1 squared plus y minus dot as a center N. So you have two cycles. So this is where, guys, remember I first introduced you to what? To the intersections of what? Of cycles. Yeah? I introduced you to the intersections of cycles before we tackled what? This question. And what I said is this: whenever once they say that you have two what cycles that intersect each other, like you have to look at three options. Number one is when you have them like this. Number two is when you have them like this. Number three is when they intersect exactly at what? At 2 point. This is 1 point. This is what? There is no intersection. And there is also this one, internal, when they intersect internal. Yeah. So yeah. So be mindful of those. So let me erase this. So now let's see this one. They say that the cycles, okay, let me use green, the cycle defined by this as a center M, and the cycle defined by this as a center N show that the cycles intersect each other at two distinct points. You see, at two distinct points. It means we are looking for what? For these ones. You still got those notes? Okay. So just gonna say, okay, remember I said whenever you have two cycles like this that they intersect at two distinct points. So this is the radii there. So again, this is the radii there. So you can call this your A, your B, and this will be the radius of what? Of this bigger cycle, and this is the radius of what? Of the small cycle. And this will be what? The distance between what? Their centers. And I said the formula, you see what? The distance between their centers AB is equals to what? Not is equals to, remember, is less than. So the distance between the center AB is less than what? The sum of what? Of their radii, which is what? RA plus RB, where RA is what? The bigger cycle, and RB is what? The small cycle. And DAB there, this is the distance what? Between their centers. We have two intersections there. You can see. So we're just going to use this formula here. If we can prove that the sum of the radii is what is greater than the distance between the centers, it means now these two cycles intersect each other at two distinct points. Yeah? Once we don't succeed to this case here, it means now this is not true. So we have to prove it. So now we have to first deal with what? We have to find the distance between the centers here. So remember, we're dealing with what? We have M and N there. So we have to find the distance between their centers. So let me see, where can I write this? I can see I still have these ones here. Okay, let me write it here. I'm just gonna divide. Okay, let me try. Let me just write it here. No? So this is 13. This is 13.2, and we are answering 13.2.1. No? So guys, you won't be given these formulas. You won't be given these formulas here. You just have to know it by heart. No? So memorize it today so that you know it for your final exam. Everyone. So now you have to show that the cycles intersect each other at two distinct points. So remember, I'm just going to write down those two equations that were given there. We are given that we have x plus 2 squared like that, and then plus what? Y minus 1, and then what? Squared, which is equals to 25. This is what? This is which one? This is the one that has the center, and this one. And then you also have x minus 1 squared plus what? Plus y minus 3 squared, which is equals to what? 9. And this one is the one that has what? A center and there. So enough the information that we have here. So now we have to first find what the distance between their centers. To find the distance between their centers, we need the coordinates of what? Of these two cycles at the center. Yeah? We need the coordinate at the centers. So just gonna say, okay, the M coordinate there, just remember that what is this? The cycle equation is given by what? By x minus a squared plus y minus b squared is equals to r squared. So now you can see it's always negative, guys. Here it's always negative. It will never be positive like that. It's like equation of a straight line is always y is equals to mx plus c. You won't find it being y is equals to as squared plus bx plus c. No. So this one is always negative there. So it means for m that you can see where you have x plus 2, it means that before or initially you have something like x minus that. And then when you multiply the negative inside, you'll have x plus 2. So you see this where this comes from? All right. So you're just going to say, it means now the x coordinate is simply what? Negative 2. Yeah? It's just the opposite of what you're seeing here. If it is positive, it's opposite of what you're seeing there. And then for y, you just take it as it is. Because you still, if you have to check, you have negative there. It means that's what? 1. Yeah? And then yeah, it's just the opposite of what you're seeing, guys. Always, if this is positive, it will be negative. If this is one is negative, it will be positive. So it's just the opposite of what you are seeing. And then for n, it's just the opposite of what you're seeing. So that's 1. Opposite of what you're seeing, that's positive 3. So let's find the distance between these two cycles, between their centers. So I'm just gonna say distance, what? It's going to be distance mn is equals to the square root of what? Remember, I will use this formula. D is equals to the square root of what? Of x2 minus x1 squared plus y2 minus y1 and then squared. So now we can term this what? Our equation 1. Not equation 1. We can term this to be our x1, y1, x2, y2. So now we start with the x1. So we start with the x2. Your x2, just read it there. So that's 3 minus your x1, that's what? -2. So you protect since you have what? The negative sign there. And then you sum it. You have y2, where's y2? So you're done with the x. So now let's read the y. You see, I made a mistake there. Let me remove that. So this is supposed to be, let me first fix this. So it is x2, where's x2? That's -2. Minus, where's x1? Your x1 is what? Look again, look what's happening there. X2 is x2. This is what? X2. That's 1. X1, that's -2. So you protect since you have a negative sign there. And then square the plus your y2. Make sure you read them correctly, guys. It's easy to make mistakes. So this is 3. So always term them, give them x1, this is x1, this is x2, so that it can be easy to read them. So your y2 is what? Is 3. Your y1 is what? Is 1. So simply subtract the y1 like that and then square. So now let me take out my calculator and see what I have. So 1 minus the square root of 1 minus 2, square the plus 3 minus 1 and then square. So I have the square root of what? Of 13 there, which is approximately 3.61, but you don't need that. It's fine like this, no? So you have the distance between what? Their centers. No? Let me picture this for you. You have those cycles. Again, they said that they have to intersect at exactly 2 distinct points. So it has to be here and then there. So this will be the radius of the bigger cycle, the radius of the smaller cycle, and this is your, let me not use a, so I'll say bigger cycle is what? If I can check here, to see if this one is a bigger cycle or small cycle, simply check their radii, no? So the one that has a bigger radii is the bigger cycle, so it means that's m, so that's m, and this is n there, yeah? So rm, rn there. So now we need to find what now? We need to find the sum of their radii. So to find the sum of the radii, I'm just gonna say, okay, rm is simply what? Is simply 25. But you're not just gonna take it as it is, guys. That's not the radii there. Yes, it is the radii. Yeah? It is the radius squared, but we are looking for r, the radius. So simply just gonna square this one here. The square root of 25 is what? Is 5. And the rn is what? Is 9. But take the square root. The square root of 9 is what? Is 3. So now let's sum this. If these things, okay, let me just approximate this. Remember, when I approximate this, it's giving me 3.61. So now let's sum these two radius then. So you have rm plus rn is gonna be what? 5 plus 3, that's gonna be 8. 5, 6, 7, 8. So that's 8 there. So you see, 8 is bigger than what? 3.61. So you say, therefore, the distance between their centers, which is what? Which is m n, is less than what? The sum of what? Of their radii. So rm, let me remove this. So rm plus what? Plus rn. So therefore, the two cycle intersect each other at, what was that? Let's go there. Show that the cycles intersect each other at 2 distinct points. So the two cycles intersect each other at exactly 2 distinct point. Yeah, just go there to answer. Just go there. You take what they gave you there. Ne? Just read the question again. That will be your answer after concluding. Ne? When you conclude, you come back to the question. Show that the cycle intersect each other at 2 points. Ne? At two distinct points. So just copy like that. And we are done, guys. You just get that full 6 marks. Ne? So now, determine the equation of a common chord. So this is very important. Is it this lesson? It's all about this thing. This whole lesson, it's all about what is this? The main lesson here is all about the cycles intersecting each other. It's very important, this one, guys. I have a feeling it's all important, I know, but this one, yeah. So make sure you don't lose it. So make sure you don't miss it. So I'm just gonna let me see where I can write this. So they say 13.2.2 determine the equation of a common chord. Just gonna write it here. I think the space is enough for this, but it's just gonna be a lot. Let me write it here. 13.2.2. So remember, we have our cycle. Right? Let me try to draw it again like that. So we have our two cycles like this. Okay, let me try again. So this is what we have now. Ish. So this is what we have. So this is the radii, Rm, Rn, and this is the distance between what? Their center. So now, remember a chord, this is what? This is a line from from the one side of a circumference to the other circumference of what? Of a cycle. But not through the center, guys. A chord is not through the center and it's not outside. Once it is outside like this, it is a tangent. Once it passes through the center, we call that what? The diameter. But once it passes from like one side of a circumference to the other side of the circumference of the cycle, we call that what? The chord. So if you have to check here, this will be our chord. This one here, where the intersection, you see where the intersection happened? You see where the intersection is? This is going to give us what? The chord. So we're looking for that. Let me go back to the question so that you understand what we are doing here. Where's my curse? Okay. Determine the equation of a common chord for 3 marks. Common chord. Common chord. So they have the common chord. This is simple, guys. Check. Common chord. That's the very important word there. So the wording is very important. Common what? Common chord. What is the meaning of common chord, guys? It means they share the same what? They share the same chord. So if you have to check, the bigger cycle and the small cycle, they share the same chord. This one in red. Yeah? They share what? The same chord. So you're just gonna say, okay, to find that chord, here is this the golden rule. You're just gonna say, go back to what? To their equations there. So you have what? You have x plus 2 squared plus what? What is that? Y minus 1, y minus 1, and then squared, which is equals to what? 25. And then again, you have what? You have negative, x minus 1. You have x minus 1 squared plus y minus what? Y minus 3 squared is equals to 9, okay? 3 and then squared is equals to what? 9. Okay, so now this is what we have here. To find that common chord, guys, you're just gonna what is this? You're just gonna subtract the two equations. Yeah. So you start with the bigger one, or from the bigger one, subtract what? The small one. So you're just gonna say, okay, This is what? This is x plus 2 squared plus what? Plus y minus 1 squared. Subtract what? The small one there. So I think first I have to like multiply out, guys. Before this step here, let me first multiply out so that this is easy for us. So when I multiply out, I'm just gonna write it here. So let's see, x time is x time is x, guys. That's gonna give us x squared. That I'm using the, what is this? Oh, there's 2 tells you that you have the squared binomial. You know how to deal with the squared binomial. You say x squared, that give you x squared. X times 2, that's 2x. Multiply that by 2, you give you what? 2x. Yeah. Multiply this by 2, give you 4x, not 2x, guys. Remember, we say what? X squared, and then x times 2, that's what? 2x. Multiply that 2x by 2, will give you 4x. And then 2 squared, that's what? That's 4. And then plus what? This one there, you have what? You'll have y squared minus 2y, and then what? And then plus 1. And then for this one here, you'll have what? You'll have x squared minus 2x plus 1. I'm using the squared binomial. And then plus, we have the squared binomial. You know how to deal with the squared binomials. That's 2, that y squared. And then y times 3. That's like 3y times that by 2. You'll have negative 6y plus 9. 3 squared, that's 9. So that's what we have now. So now you just gotta say, okay, guys, you can do it all in one, yeah, all in one. So without going through those things like subtract, and then after that you'll multiply out. So we just gotta say this is the bigger cycle, 1f x squared plus that plus y squared minus 2y plus 1. Okay, let's 4 plus 1, that will give you 5. So it means we have plus, okay, let me arrange them in odd. We start with the higher power, so x squared plus y squared, and then plus what? Plus 4x minus 2y. 4 plus 1, 5, and then subtract from the small cycle. Subtract the small, subtract the small cycle from the bigger one. So you have x squared plus y squared. And then you'll have what? Negative 2x, negative 6y. 1 plus 9, that's 10. Don't forget you have the 12, the 25, and the 9. So you simply say 25 subtract 9. You see? So this is very simple, guys. I have a feeling, guys, that this is gonna be there. You see, this one, they're talking about 2 cycles intersection. It cannot be the same thing as like they tell you what 2 cycles intersecting at 2 distinct points. It can be 1 distinct point, guys. So be careful with that. I'll give you some notes after this now. So now you can see that this one here and this one, they're going to rationalize this. This rationalizes. So you see what we have, 4x minus, okay, minus negative times negative will give you positive. 4 plus 2, that's 6. So 6x. Negative 2y, and then what? Plus 6y will give you what? Will give you 8 there. So 6, 7, 8, not 8. It will be negative 2 plus 6. That will give you what? 4. So positive 4, not 4. Positive 4, negative 4. 4y. And then you have 5 minus 10. That will give you negative 5. So you have a negative 5, which is equals to, what is that? 25 minus 9. That's 16. So 16. And then now, look what's happening here. We have 6x, we have 4y, And we also have what? We also have that. So what can we do now in this situation? Look what we have. We can use those coordinates, ne? Yeah, we can use those coordinates, guys. Cool. First, let's check if we subtract correctly. That's 5. Take away 9, or take away, yeah, take away 10. You'll be left with -5. And then take this to the left. So you have 6x plus 4y will be what? So you have 16 plus 5. This will give you 21. So you have 21 like this. So now you are here. So what we can do is to make the substitution now. No, is to make the substitution. So we can what is this? Where's that? Where those points? I'm looking for those points there. So let's use those points. I'm just gonna use M there. So let's use M. So if you substitute M, let's see. If you substitute M, you have a negative. No, 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 no. You see, I'm trying to solve, and the question didn't say that. This is the equation, guys, of the chord. Determine the equation. See, determine the equation of what? Of the common chord. Determine the equation of what? Of the common chord. Determine the equation of a common chord. So this is the equation of a common chord. Yeah, this is the equation of a common chord. 6x plus 4y, which is equals to 12. But a chord, you know, is a straight line, guys. So now let's make y the subject of the formula. So to make y the subject of the formula, you see, I wanted to go beyond what was being asked. I wanted to like find the y, the x. You see, guys, it's gonna be complicated. So make sure you read the instructions first. Make sure you understand the instruction, and that's very important, because if you don't understand the instructions, like you don't even know what you're doing about. So make sure you read the instruction very well before uh being quick to answering. So let's divide them. So 4 that gives us y. So now 2 goes into 3 how many times? Oh, 2 goes into 6 how many times? 3 times. To 4 2 times. So I think that will be 21 over 4. 21 divided by 4, that's 21 over 4. And this will be our answer, guys. This will be our answer, eh? So this is our answer there. So we are done with this question. So that was a lot. Let's cross check. 6x, where's the 6x? 4 into that. So remember, this times that to give you 2x, 4, 5, 6. Yeah, it's fine like this, guys. Let's take a look at the next question so that we can finish this on time. Né? Remember, I'll give you some notes after this. Né? So, okay, let me check this to a side. The diagram below consists of the 2 cycles which touch each other externally. You see now, you have 2 cycles that touches each other externally. So if you were asked, guys, to calculate if they really touch each other external, the equation, you'll use what? This formula. The distance between A, B is simply what? It's simply equals to what? It's simply equals to the sum of the what? The radii. So that's the equation that you would use there. You understand? So now, so let's see, the smaller cycle has its center O at the origin, blah blah blah. Seems like something. It seems like what we have. Okay, so we can see that CA is a tangent to that. CD is a diameter, blah blah blah. So guys, let's get into the questions. Give a reason why the points OC lie on a straight line. Guys, let's hear the question. Give a reason why the 2 points or why the points O, C, and D lie on a same straight line. In other ways, they are saying that O, C, D are what are collinear points. Remember, collinear points, these are points that lie on the same straight line. I gave you an example that we have A, we have B, we have C. They lie on the same straight line. Whenever you have points that lie on the same straight line, they are called what? Collinear points. So now they're saying give a reason why O, C, D are what are collinear points in other ways. Yeah? Or they lie on the same straight line. That's the same thing. So now if you had to check, let's see. The reason why they lie on a straight line is because what they the two cycles intersect what each other externally. Yeah? Because you can see that the center this line passes through what through the center D and then what and then O there. So let me make sure that you understand that they touch each other external. You can see the two cycles touch each other what external. So now this straight line here passes through what passes through the center of what of D, and then what and then to where the what is this where they intersect each other external. So that's the answer there, guys. So I'm just gonna say there or simply say there two cycles intersect each other externally. So whenever you have two let me write that nice. So the two cycles intersect each other externally. So whenever you have two cycles that intersect each other externally, you have that case there. No? So you can see that this line here, you see, you have that line that passes through what this center D, and then what and center O, and also passes through what O. What is this? You have this line, as you can see this line, you can see this line. It passes through what? Through where the intersection happens. They were through the point A there. So that's the reason, guys, why these lines O, C, D lie on a same straight line. You see, because of what? Of this line. This line, it passes through A, where the two cycles intersect each other externally. So I tried my best. Look what's happening there. I tried my best, guys, to explain this. Now, okay, calculate the gradient of OC. OC, where's OC? Okay, OC, remember, this is the origin there. So the 0, 0. So the gradient of OC will be easy. Just use the gradient formula. So MOC is going to be changing Y all over changing X. So remember, I told you always name them X1, Y1, X2, Y2. So your Y2 can see it's -2 minus your Y1 is going to be 0 there for O all over your X2 is 1, then minus 0. So this will give you what? This will give you -2. This will give you -2, guys. Ish, look what's happening there. Okay. So this will give you -2. Né? -2 minus 0, that's -2. 1 minus 0, that's 1. -2 divided by 1, that's that. Hence show that, you see, hence meaning there is a connection between the previous question and this one here. So hence show that the value of t is equals to what? Is equals to 3. the value of t is equals to 3. This one there. So we have to show that the value of what is this? The value of t is equals to 3. We can use the midpoint formula, but can we use the midpoint formula? Let me see. Are we given the coordinate of E? They didn't say anything about E. We are not given the coordinate of E, guys. I just wanted to use what the midpoint formula. So, but let's see what we can use there. So now, remember, we just calculated what is this? We just calculated what? Remember this, that OC and to D there, they lie what? On the same straight line. They lie on the same straight line. So this one, see, they lie on the same straight line. So whenever they lie on the same straight line, it means the gradient of what? The gradient of what? Of OC is the same as the gradient of what? Of CD, and it's the same as the gradient of what? Of OD. This is when you have what? Collinear points. This is collinear. They help each other. Collinear points. So you'll have that. So now we're just gonna use the gradient formula, guys. Yeah, gradient formula. Follow my steps. So I'm just gonna say, okay, let's find the gradient of what? Of this. Or we know exactly what the gradient of what? Of this line CD. Since OC, the gradient of OC is what? Is -2, and will be the same as the gradient of that, and then blah 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 blah. So I'm just gonna answer this here, 19.3. So you're just gonna say, okay, now you have -2. Is it -2? Yes, you have -2. That will be your gradient, and then you can call this your x1, y1, x2, y2. Remember, to find the gradient, you say change in y over change in x. So change in y is y2 minus y1, x2, x1. And then let's first deal with the top part. You have what? -2. You have -2 plus 6. That will give you 4. So you have -2, which is equals to what? 4 all over 1 minus t. Do the cross multiplication. You'll have 4, which is equals to -2 into 1 minus t. So now you can either multiply in or divide. So I'm just gonna divide like that. So this and this rationalizes. 4 divided by that will give me -2. Then I'll give you -2. So, and then this I'll have 1 minus t. Take this to the left, I'll have -2 minus 1 is equals to -t. Therefore, t is simply 3. Because -2 minus 1, that's -3. Multiply both sides by negative, you'll have a positive value of what? Of 3 then. So t being 3. So therefore, t is equals to 3. So now, determine the equation of the tangent AC in the form of what? Of y is equals to mx plus c. So guys, to determine the equation of AC, that's very simple. Why? Why am I saying so? Everything is simple. Here, look, this is the straight line, the tangent, no? And then you have this line. You see, they bisect each other, they meaning they form what? A 90-degree angle. What did I say? Whenever you have two lines that bisect each other, what do you know about two lines that bisect each other? You know that the product of their gradient is equals to what? -1. So if you know the gradient of the first line, you can find the gradient of what? Of the second line. So just gonna use this what rule there. So just gonna say, okay, m1 multiplied by m2 is equals to -1. Your m1, this is the gradient of AC. Remember, everything in this line, they have the same gradient. So it means AC. So it means now we're just gonna say, okay, This is the gradient. So negative 2 multiplied by m2. This is going to give you negative 1 divided by negative 2, negative 2. This rationalizes. So therefore, your m2 is simply 1 all over 2. But you're not done. They said determine what the equation of the tangent. So to determine the equation of a tangent, they're just gonna say, now I have y is equals to what? Is equals to 1 all over 2x plus c. Because you have determined the gradient. No? You need what now? You need the value of what of c there. To find the value of c, you go back there where the intersection happens. You use that coordinate, which is c, 1 and negative 2. So negative 2 for y, 1 and what for x. So let's go back there and make sure that that's correct. So 1 and negative 2. So this will give you a half, and then you'll have something like a negative 2 minus a half, like that. Then you'll have all over 2. Here you'll have negative 4, and then minus 1. This will give you minus 5 over 2. So minus 5 all over 2 as your value of c. So therefore, y is equals to 1 all over 2. So always the equation of a straight line, guys, has to be y is equals to. Don't leave it there after calculating the value of c. You leave it there. Make sure you conclude and say y is equals to. I know there is that other equation there that says y is equals to minus y1, blah blah blah. But this is one, guys, the simple one. Straightforward, this one. So make sure you don't miss anything there. So that's what you will have there. So that's what you will have there. So now let me confirm minus dot, and of course it's the same thing. So now we are here. Calculate the coordinate of E. You see, now it's easy to calculate the coordinate of E because we know the value of D there. The coordinate of D is 3 and what, the negative 6. We have shown here that t is equals to 3. T is equal to 3. So t UHD becomes what? Your midpoint, guys. It becomes what? The midpoint. Why midpoint? Because this is the radii there. Radii 1, radii 2. You sum them, they will give you what? The diameter. You divide them, it means now this is the midpoint. You see? So once we divide by 2, that's the midpoint. So it means this is the midpoint. So just gonna use the midpoint formula. So let me see 19.5. Let me answer it here. So 19.5. Is it 19.5? Let me cross check. All right. So remember the midpoint formula: x1 plus x2 all over 2, y1 plus what's happening there? Okay, y2 all over 2. So now we're just going to say x at e, xe plus x at what? At c there. Remember, let's say we want to find the midpoint of what? Of CE. Now our answer will be what? This 3 and what? And negative 6. But now we have the midpoint. To find those values there, to find those values, you are like reversing, guys. Ne? You're working backwards. You see, work backwards. So now know how to work backwards in maths. So now it will be x to what? To your c there all over 2. This has to give you what? The coordinated what? At d. So this has to give you xd. So it has to give you xd, guys. And then the y at e plus the y at c all over 2. This has to give you what? The y at d. So the x at e, we don't know that, plus the x at c, that's 1 there. So that's 1 all over 2. This has to give you what the x at d, which is what 3. To solve this, you do the cross multiplication. 3 times 2, 6 is equals to x e plus 1. Take this to the left. Therefore, x e is what? 6 minus 1, that's 5. So now what about this one here? So this one will say this is y-e, which you don't know, minus, because I saw I have negative, so it'll be negative 2 there, so plus or minus. Not gonna change since this is just a positive value. So now, positive sign, and then the y at this one is negative 6. Cross multiply, negative 6 times 2, that's negative 12. And then this will give you y-e minus 2. So now, negative 12 plus 2, when you take this to the left, it means now therefore y-e is simply 10, isn't it? Negative 10. And that is to make sense, guys, when you read it, this is this. If this is 3, it makes sense that this is 5. And if this is negative 6, it makes sense that this is negative 10. So that's it. E is simply what? 5 and negative 10. So E is what? Is 5 and negative 10. And we are done. So we can conclude here our answer that E, since they were looking for coordinates, 5 and what? And negative 10. So now determine the equation of another 6 marks. Guys, another 6 marks. Remember that first 6 mark. You see, that's why I'm saying this lesson is very important, that, guys, and you should pay full attention here. Guys, I have a feeling that you'll be tested on this, guys. Yeah? Cycles intersecting each other, externally, internal, what, blah, blah. Remind me to give you some notes after this, no? So now determine the equation of a cycle passing through the points A, E, blah, blah, blah. So determine the equation of a cycle passing through the points A, C, E. If A now is given, A, C, E, A, C, E. So A, C, E. So you have a cycle like this. Because they said it passes through AC, so this is the cycle, guys. Cycle. We don't even know the center, but we're given the coordinate of A there. So determine that the equation of a cycle passing through the points AC and EC. Blah, 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 blah. Do we know the coordinate at C? Yes, that was like, I thought as I've seen it, guys. Yeah, what I saw there is 1 and negative that. What is E? E, we just calculated it to be 5, negative 10. It's like this question, it's like everything that we have covered so far for this question was leading us to this one, because you can see we need the so you see, guys, this thing of skipping questions. When you skip questions, imagine now, guys, you were going to skip everything like this. 21, take your calculator now and say 21 divided by 150 times means what? 100. Tell me that, and tell me that how much is the percentage there. You'll see that you'll have lost a lot of percentage there out of 100%. Don't forget. So enough with the talking, guys. Let's see. Determine the equation of a cycle passing through these points. You have A, you have E, yes, you have E, you have C. So this is C in the form that. Okay, that's very simple. I always say that's very simple, né? Yeah, simple. So now you're just gonna say, all right, let's say, okay, let me first write, see what's happening there. So it's starting to misbehave this thing. Please, no. Please, please, please. So 19.6. We have x minus what? Okay, look what's happening there. has to be b if I'm not mistaken squared plus y minus b squared, which is equals to r squared. Yes, let me fix that. Y minus b and then squared is equals to what? R squared. So this is what we have, guys. Remember, we have points A, which is what is that? 1 and -2. And then what is that? I remember E, which was -5, 8, 10, +5 and -10. And then what was the other one there? A is 5 and 0. 5 and 0. So meaning this is C, not A. Let's make sure that we got them correct. E5, -10, 1, negative that, A5 and 0. Yes. So now, remember that these points, guys, they're what? They lie in this cycle. They are on this cycle. Just think of it as A being there, C being there, E being. They lie on that cycle there. They lie in the cycle there. So we're just going to say, let's substitute those equations and see what are we forming next. So let's see. We start with what we're given. So you start with this the A there. So A, let's see, it will give you what? You say x minus the coordinate of A is what? Is 5, then squared plus there. See where I'm substituting these values, guys. Making a big. These values are for the center of the cycle. We don't even know the values of the center of the cycle. So make sure you substitute them where there is x, where there is that thing. So x is what? Is 5 minus 8 squared plus the y is what? Is 0 for what? For A then. And then b and then squared, which is equals to r squared. So now when I solve this, I see I'll have what? I'll have positive into negative that. Yeah, let me write that nice. Yo, is this misbehaving? Whoa. So I have a negative b into squared, which is equals to r squared. So now you say e, and then this will be your x at e is what is 5 minus a, and then squared plus your y at e is -10 minus b squared is equals to r squared. Your c is what? You have x is 1 and then minus a squared plus your y is what? Is -2 minus b and then squared is equals to r. So let's see if we have something that looks more like the same. You can see equation, you can call this your equation 1, guys. Yeah? So let's call this our equation 1, equation 2, equation 3. So let me use red. It's time to use red now. I don't have a space. You see, I don't have a space. I'm just going to take this side. Yeah? So we're just going to equate equation 1 and equation 2, guys. So let me take this up here. I think I'll have a space. So I'm just going to take it up, guys. Yeah? So I'm just going to say equation 1 next to squash to what? Equation 2 there. So now equation 1 is what? Is 5 minus a. Y equals to equation 1 equals to equation 2. All of them are equal to r squared. You see, all of them, they're equals to what? R squared there. So you can equate them anyhow you want, but as long as you know what you're doing. Yeah. So I start with this so that this and this will rationalize. So I have plus what? You can see since 2 is an even number, I'll have b squared. which is equals to what? Which is equals to 5 minus a and then squared plus what? Plus negative 10 minus b and then squared. So now when you take this to the left, this and this, they are the same, so they're going to what? Rationalize. So you simply don't want to waste time there. You simply say this and this rationalize. So you'll be left with what? With b squared, which is equals to this. So now let's multiply out. This 2 tells you have the squared binomial. 10 squared, that's since 2 is an even number, to give you 100. No? Give you 100. And then negative 10 times negative b will give you a positive b. Multiply that by 2. It will give you what? It will give you 20. 10 times 2, that's 20. So plus 20b, and then plus what? Plus b squared. The b squared and the b squared, you can see they are going to rationalize. Take this to the left, you have 100 is equals to negative 20, a positive 20. And then divide by 20. Divide by 20. I think this is 5. 20 is giving 5, guys. 100 divided by 20 is 5. 100 divided by 20. Okay. 100 divided by 20 is 5. Yes. So these and these rationalize, this and this rationalize. 10 divided by 2, 5. Therefore, b is simply what? Negative 5, because of that negative. So we are done finding b. So now we need to find what? A there. To find a, let's see, we are just going to substitute this to equation 1 and then again equate equation 1 and equation 3. So just going to say, now for equation 1, okay, equation 1 let's discuss to what? Equation 3. So now we have 5 minus a squared plus, remember, b squared there, so to give you like negative, remember I'm replacing the negative into negative 5 and then squared. So negative times negative will give me positive. This will give me 5 squared, which is 25. This is equals to r squared. Oh, I'm equating now, so it has to equals to that part, the other part there. So it's equals to 1 minus a. Let's see if I don't have a space there. Right? So it's equals to 1, what was that? 1 minus a squared, which plus negative 2. But what is b? B, you say minus, I'm here, guys, I'm here. Don't lose focus, I'm here. Minus, and then b replace b, it will be negative 5. And then you square it, is equals to your r squared. Not r squared. Remember, everything is equals to r squared. So just leave it like that. So you have something like this, no? So now I can multiply this out. I'll have what? I'll have 25. Since this 2 tells you have a square binomial, 5 squared is 25. 5 times a will give you negative 8 times that by 2 left negative 10 a, and then a squared give you a squared, then plus 25 squares to 1, and then this will give you minus 2a plus a. This will give you oh, I can see here, let me use my calculator on that. Excuse, negative 2 minus 5 squared, I have plus 9. So let's see, do we have things that rationalizes each other here? Yes, this we have to get a squared. So this that rationalizes. So negative 10a plus 2a, when you take this to the what? To the left. Yeah, you'll have what? Negative 8a. Then take the constant to the right. So 1 plus 9, you'll have what? 10. And then from 10, subtract 25. Oh, okay, see, 25 and 25 will give us what? 50. So you'll have negative 50 when you take it to this side, and then plus 10. So negative 8a is equals to what? So 50 into that will give you negative 40. So you have negative 40. So you have negative 40 and then divide by 8. Divide by 8. So I have negative 5. So this rationalizes. So a is simply positive 5, not negative. So positive 5. Because 40 divided by 8 is simply 5 there. So I have a to be 5. So it means now the equation will be what? The equation therefore is simply what? X minus a squared plus y minus what? Minus b squared, which is equals to what? R squared. So now you have the a. The a is what? Is 5, so place it there and then squared plus the y minus and then minus 5 squared. This will give you positive. So let me just write positive 5. So it is y plus 5. Then squared is equals to r squared. To find the r squared, we're just going to use the distance formula. Then, or simply substitute any value there. For example, you can replace with a there, since a is just 5 and 0. So this is your x, your y. So your x is what? What's happening there? Your x is 5 minus 5 squared plus your y is 0 plus 5 and then squared is equals to r squared. This one, 5 minus 5, that's 0 squared, that's 0. So this goes away. 5 squared, that's 25. And then r squared. So take the square root. This rationalizes. So r is simply 5. Everything is 5. Everything is 5, guys. So now let me just conclude here. So just say therefore, now the equation becomes what? X minus 5 squared plus y plus 5 squared, and then which is equals to, of course it will give us 25. If you see r squared there, r is 5 squared is 25. So this would be your equation there. Let's check if we answered what they asked us. So determine the equation of the second person through the point, blah 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 blah. So that's it there. That's what you have. I don't think I made some errors there. Because let me see this 120 b squared that okay. Then this 25 and then that and then that and then that and then 1 minus that and then what? A squared and then 9. Let me check this side. Negative 2 minus or plus 5 squared, still 9. So 1, 9, that's 10, 25 to that will give me 50 to that, negative 40. And then, yeah, that's it. So this is the last question here. This is the last question. If cycles with center D and okay, if a cycle with center D and equation given in this format has to cut the cycle with center O twice. Give all possible values of R. Give all possible values of R. So this T, what he didn't even give us the value of T. There's people, I need the value of T. So I'll just assume that T is what we got there. So it means now this equation is just gonna be X. Okay, let me write it below so that it doesn't seem like it was the one that they asked us here. So maybe let me just write what we got here is X minus 5 squared plus y plus 5 squared, which is equals to 25. Let's confirm if it's what we got there. -5 plus that, yeah, it's the same thing. So okay. So now I'll just assume that this is x minus 3 and then squared plus y plus 6 and then squared, which is equals to r squared. Yeah, I'll just assume like that. So if a cycle with center D, and the equation is says to cut the cycle with center O twice. Where's the cycle with center O? Cycle with center O, okay, it is the small cycle, so they have to cut twice. Is that what they said? They have to cut the cycle center O twice. Okay, center O twice. So this is what we have there. So what else am I given? Okay, I think that's it. So now let's get into the question 19.7. So 19.7. We're given that equation is y minus minus t and then squared plus y into what? Y plus 6. Okay, y plus 6 and then squared, which is equals to r squared. So now remember, whenever we have two cycles that touch each other exactly at 2 point or twice, we are looking at this. So the distance between the center AB is less than the sum of what? Of their radii. That's what we have there. So let's find the what is this? The equation. Let's find the value of the radius of what the small cycle there. So to find the small cycle, I'm just going to use points O and C there. So just the square root of what? Of y2. So I hope you can see that. So my x2 is going to be 0. No, that's 1. You can see for C there, x2 is 1, so 1 minus 0, and then you say squared plus, and then your y2 is -2 minus 0 there, then squared. So let me see what's that. So squared plus, so I'm getting square root of 5. So this is the square root of 5. It means now the radius what is just, it's just the square root of 5. So I have this, I have the radius of the smaller cycle. Now to find the radius of the bigger cycle, let me go back to the question again. I think I'm missing something. If the cycle with if the cycle with the center D and the equation blah 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 has to cut the cycle with center O twice if all possible values of A, or values of what? Of R. Okay, fine. So just like what I said, I'm just going to assume that one there. So this is x minus 3. T is 3, so squared, and then plus y plus 6, and then squared, which is equals to r squared. Like that. So now, what's next? Is to find the distance, no? So I'm just going to use this. Remember, the distance of the smallest, what is this? The equation of a smaller cycle is just going to be what? It's just going to be x squared plus y squared, which is equals to r squared. So r, so the square root of 5 there. So this in this rationalizes, you'll have 5. So that's the equation of what? Of the smaller cycle. So to find the distance between the centers, so that's D. So you'll say the square root into y2, y1. So let me see. This is 0, remember? So I'm just going to use these points. So x2, I'll say it is what? It is, remember, when you take these values out, you'll have 3 minus 6. So it means I'm just going to term this my x2. So this is 3 minus x1 is 0. We know we don't like wasting time there, so we can't waste time there. So simply square this one and then plus your y2 is negative 6, and you can't say minus 0 again since you know 0, it's not going to change anything. So let me remove this. So now let me punch and see what I have. So the square root of 3 squared and then plus negative 6 squared. This is giving me 3 square root of 5. Yo, yeah, 3 square root of 5. That's what we have there. So now I'm just gonna introduce something we call, what is this? The absolute value. Né? The absolute value of a function works like this. Let's say that you have the absolute value of x that is less than a. So the answer here is just what? It's just x. So you say is x less than minus a, x greater than what? Than a. So this is what the answer. Wherever you have this condition like this, x is what is greater than negative a, x is greater than what? A. So what if it's the absolute value of x? These two lines, guys, you see these two lines like this? We call this is the absolute value. These two lines like they're called what? The absolute value. So now let's say the absolute value of x is greater than a. What will be our values of a then? So it would be what? It would be a greater than what? Greater, not a. It would be x greater than a. So x greater than a, and then x less than what? Negative a. So in other words, you say x is greater than a, or what? Or x is what? Or negative, or x is less than negative a, like that. So this will be your answers there. So I'm just gonna use this thing to solve this question there. Yeah, that's a lot there. It's a lot of math. Math. It's limited. It's not limited. I'm kidding, guys. It's infinite. Cannot learn a lot. So now, this is what we have there. So to find those values, remember, we have to use this equation that you see up there. No, that you see up there. So now, the distance between their centers, I'm just going to say AB, guys. AB, for instance, or simply term it D, like this, D. So this has to be less than what? The sum of the radii. So I'm just going to say R1 plus what? Plus R2. And again, this has to be greater than what? The absolute value of what? Of these two things, of R1 minus what? R2. Yeah, it has to be like this, guys. Then, so whenever they say, let me go back there. I know this question is gonna come. So whenever they say if a cycle with a center D and you are given an equation, and they say he has to cut the center, or he has to cut the cycle with center O twice, and they say give all possible values of R. This is what you're gonna use. No? This is the golden rule. This is the golden rule that you're gonna use. Only if they say that the cycle with the center D and the equation has to cut the cycle with center O twice. Use what? That equation there. This one that you see here, this other part here, remember I said you can have again a center or the bigger circle and a small cycle inside what? the bigger cycle. So if you have to check the radius of what of the small cycle, you have it like that, and you have this the radius of what of the bigger cycle. So if you have to check the radius of the bigger cycle is what is greater than the what the smaller cycle then. So the distance between their centers like that, you're just gonna use this formula. The distance between AB is just gonna be what? It's just gonna be less than R1 minus R2. So this is the formula that you will use then. Or simply say squares 2. Let me just, yeah, it is like that, right? So I'm just gonna say dA is greater than R1 minus R2. So whenever you have a cycle inside another cycle, now this is the equation that you're gonna use. The distance between their centers is greater than what? Is greater than the what is this? Subtractions of what? Of their centers. Yeah. So now I'm just gonna use this thing. So it should be done by now, guys. Yeah. So I'm just gonna move using this thing. So now you know the distance between their centers, né? Is what? Is 3 square root of 5. So guys, use this formula when they say what? A cycle cuts another cycle what? Twice. Calculate the what is this? The values of R or the possible values of R that you're gonna get. You use this formula. So you put the distance that you have there between the centers. Your R1 is what? So let us let R1 be what? R for what? For the bigger cycle. Yeah? For the bigger cycle like that. So I'm just gonna leave it like that. So R1 is the radius of the bigger cycle. So I'm just gonna term it R there, and then R2 is the small cycle. So it's just gonna be plus the square root of what? Of 5, which is less than the absolute value of the bigger cycle R, which I said is the same as R there. R1 is the same as R, and then minus what? The square root of 5. So now this is what I have. So now let's start with the left hand side. The right hand side, I mean. So the right hand side is gonna be this part. So let me remove that. So just gonna say, okay, we have the 3 square root of 5. This has to be less than R plus. Math is a lot. You see, guys, math is a lot. Yo, yeah. So now take this one to the left. So you left 3 square root of 5 minus square root of 5. This is less than R. So now let me take out my calculator and see 3 square root of 5 minus square root of 5. This will give you 2 square root of 5 there. And again, guys, you know, they call this what is this? This golden rule. You see this golden rule? Let me just highlight it here. This one here, they call it the sweet point. They call it the sweet point. Yeah, the sweet point. It's where like two cycles intersect each other internally. So they call it the sweet point. So it's just you're just gonna use this formula there. Yeah, I told you maths is a lot. Then don't blame me. Blame yourself for choosing math. So now we are done with the right hand side. Let's go back. Let's deal with the left hand side then. So the left hand side is just from that 3 square root of 5 to the left. So you have the absolute value of R minus the square root of 5, which is less than what? The 3 square root of 5. Remember, I said something. I said the absolute value. Let me introduce red so that you can remember since I used red. So remember, I said look what's happening there. I said the absolute value of x, which is less than a. This is what? This is x less than positive a, x greater than what? Negative a. So this is exactly what we have here. So just gonna say, okay, This thing is the same as that, né? So it means your what is this? The middle part is r minus that. Yeah. So we're just gonna say r minus the square root of 5 into this has to be less than 3 square root of 5 less than negative 3 square root of 5. But we know something that what is this? The 3 or what is this now? That r is greater than 2 square root of 5, guys. Let me approximate this value and see. Negative 3 square root of 5 is approximately negative 6.7, approximately 6.7. And then 2 square root of 5 is approximately 4.7, né? 4.47. So now, this part here is not going to help us, né? Since we know that we already have one possible value of r that says r has to be positive. You can see r is positive, né? It has to be greater than what? Greater than the square root of this what is this? It has to be greater than 2 square root of 5. So r is positive. Look, now I'm substituting with that value there. So you have to say it's greater than 0, né? Since r is always positive. So you shouldn't say it has to be greater than negative that. Né? Since already we have that value that says r has to be greater than that meaning that r can only be positive. Yeah, we can only have the values of r that are what? That are less than 0, guys. So it has to be greater than 0. So to solve for r, you take this to what? To the left. So it will be square root of what? Of 5. And then what again? No, you don't take this to the left. Look what's happening there. You multiply. Yeah? So okay, let me remind myself a bit. So if I have something like x minus 1, which is what is this? Which is less than 1, less than negative 1. To find the x, I'll take this to what? To the right and take this to what? To the left. So I'll have x being what? 2, and then x being what? 0 there. X, look what's happening there. X being greater than 0. So that's what I will have there. So it means here is the same story, né? So I'm just gonna say, okay, take this to that, you'll have the square root of 5, and then which is less than r, and then take this to the left. Let me see. Ooh. 2e to that plus the square root of 5. I have 4 into square root of what? Of 5. R into that. So let me see, square root of 5 is what? Square root of 5, approximately 2 point something. Fine. So these are the possible values of x, guys. Oh, of r, I mean. These are the possible values of r that you can have the. So I hope that was clear. So now let me see, 3 square root of 5, and then plus the square root of 5. Okay, I see I have what there. So you can just ignore this part. So therefore, the possible values of r is that r has to be between 4 square root of 5, but greater than what? 2.5, 2 square root of 5. So this is it, guys. It was complicated, guys, but yeah, that's the answer then. Because remember here, you have what? If I didn't remove this, let's say you still have that part there. You'll have what? You'll have negative 3 square root of 5 negative 3 square root of 5. Take this to the right. You'll have what? You still have a negative what? This part. You'll have negative this part. You see? You'll have negative 2 root 5. Before you see that the value of r is what is positive, can only be a positive value there. So this one is not gonna work. So you'll see we ignore this part there. So therefore r has to be what? Between 2 square root of 5 and the 4 square root of 5 there. So that's it, guys. That's it. So yeah, we're done. Oh, notes. I forgot. So let me see, where can I write this? Yeah, that was it. And guys, let me see. Yeah. So now let me just give you some notes. Yeah. So now intersections. Look, the spelling there. Intersection of cycles. Intersection of cycles. So number one, this is when you have they do not intersect. This is when you have a bigger cycle like this, and then a small cycle like that, and then you have a radii. You can call this your r1, and this will be your r2, and then this will be the distance between what their centers. So that will be the d there. So you can term this is your okay. Let me say this is ra, rb. So this is your a, this is your b. So now, whenever you have two cycles that do not intersect, the equation that you are going to use is that is this: the distance between a, b, between their centers has to be greater than what the sum of what of their radii. So ra plus rb, and then number two is when you have a cycle like this. So now let me just take this down. So it's when you have a cycle like this and a cycle like that. So now here is when they intersect at 2 points. So look what's happening there. You have RA there. This is A. This is B. So RA and then RB. So this will be the distance between what? Their center. So whenever you have this, in this case, where they intersect at 2 points, the formula is this: the distance between A, B is simply less than what? The sum of their radii. So RA plus RB there. So RA plus RB. And then number 3. So this is when they touch externally, yeah. So this is when you have a cycle like that, and then another cycle like that, then you have something like this. I can call this A, my B. So RA and then RB. So the distance between their centers is termed to be what? D. So now when you have this case that they don't, or they touch externally. Externally meaning like exactly at 1 point. You can see they touch exactly at 1 point, like a tangent. It touches the cycle exactly at 1 point. So meaning now the equation that you're going to use is D, which is the distance between their centers, which is equals to what? R1 or RA plus RB. So the sum of what? Of their radii. So that's the formula there. And then number 4 is this one, the internal one. So let's say again you have another cycle like that, touch internally like that. This is the one that we used to calculate the previous question, eh? The last one. I'm talking about the last one. So now you have that. How can I draw this? Okay, now I'm just gonna say this is the radius of the bigger cycle, radius of the small cycle. This is RA, this is RB. So you see the distance between what? Between their centers. So small, ne? So that's why you say R, that's why you say D, the distance between AB, simply what? You subtract the bigger cycle, the radius of the bigger cycle to what? From, or subtract the radius of the small cycle from the bigger cycle, RA minus RB. So this is the formula that you'll use here. So this is when they do not intersect. Intersect. Do not intersect. Yes, do not intersect. Let me see what I have there. So number 1, they do not intersect. They intersect. This is when they intersect internal, guys. So let me remove that. So internal, I'm just gonna say internal intersection. Intersection, yeah. I think that's it, guys. That I have for you, yeah. Yep. So, but if you're to combine every these 4 things here, or just 2 things, you see that you'll have that street point. That equation of what? Of street point. You can see it's R minus RB, and then this part here, where they intersect what? At 2 points. Because that equation was like determine the value of R, or the possible value of R, where the 2 cycles intersect each other exactly at 2 points. So that's it, guys. So that's what I have for you. It was a lot, no?